Find the quadratic function in vertex form to fit the following graph. As a reminder, the vertex form of a quadratic function looks like this. f of x is equal to a times x minus h quantity squared plus k, and the vertex point is the ordered pair hk that appears right here in the vertex form of the function. Now on this graph, we're given the vertex point, which is the ordered pair 2, 1, and so we can use 2, 1 and plug that in for hk, and that's where we start. So f of x is going to be a times x minus the x coordinate of the vertex, which is 2, quantity squared, plus the y coordinate of the vertex, which is 1. We're now pretty close to having the function, except for the value that we need to find is a. In order to determine what the value of a is, we're going to use the only other ordered pair that we're given that is a point on the graph. We know that any graph is the collection of ordered pairs that are solutions to the equation. So the ordered pair 0, 5 has to be an ordered pair solution to the function itself. So we'll plug 0, 5 in for x and y, and whatever a value makes that ordered pair an ordered pair solution will be what we use right here. So we plug 5 in for the y. We leave the a variable in because that's what we're trying to solve for. We're going to plug in 0 for the x value minus 2 quantity squared plus 1. So we just plugged in 0, 5 for x and y. And now we'll solve for a. First, let's simplify this. 0 minus 2 is negative 2. Quantity squared is going to be positive 4. So we have 5 is equal to a times 4 plus 1. We then subtract 1 from both sides and get 4 is equal to a times 4. And then to solve for a, we simply divide both sides by 4. And we get that a is equal to 1. So we'll take this quantity back up to our function, and we're now able to write a completed function that represents this graph, which is our a value is 1, and just for emphasis, I'll actually write that 1, times x minus 2 quantity squared plus 1. Of course, this 1 on the front is not necessary. A more simplified version of the function would look like this.